Supplemental math videos from Circle Christian School. Shapes and their similarity. They are proportional. All right, here's the big thing. It's apples to apples, oranges to oranges, big shape to small shape, big side to small side, big side to small side. It's all about the setup. I want to talk a little bit about proportion before we start working with it. It is really just basically a ratio equals a ratio, an equivalency, a comparison that equals a comparison. Now, starting with the first one here, 4/5 equals 16 over 4. We have a couple little things that are going on here. First, you'll notice that you have this small fraction, and then you have something that looks seemingly like a larger fraction. And then you have kind of a small number, and then a large number, and a small number, and a large number. It's a little bit of what I was talking to begin with. It's all about the setup, that there's generally, with proportions, a smaller item compared to a larger item, and then their parts. The small will compare to the small, and the large will compare to the large. Now the next thing is that we know that what happened from the small to the large is that if we multiplied the top by a 4 and the bottom by a 4, that would give us the resulting 16 over 20. So this is what we say has a scale factor of 4. It got larger by 4. Alright, taking a look at the next one, you'll notice what did it take for the 8 to get to a 32, and we'll just check to see if that's also what happened to the 25, and we go, yes, great. And here again, it had kind of a scale factor of 4. Ooh, my C's kind of funny there. Let's see if I can fix it. I have white out. There we go, scale factor of 4. Now we're going to take a look at the next one here and see if it has a proportionality to it. Like, what did we multiply the 6 by to get a 20, and what did we multiply the 14 by to get a 42? Because we're going to see if they're actually proportional to each other. That is, that they have a scale factor that is even between the two. I'm having a hard time with the 6 times what gives me a 20. Well, let's check out the 14. 14 times 3. Okay, that gives me a 42. But if I multiply the 6 by a 3, I get an 18 instead, and that's not going to work. So we know that this one is not proportional. In other words, it doesn't have a ratio that equals a ratio. Okay, one thing that you can notice that also happens with these is generally what we have is a fraction that equals a fraction. And anytime that you have a fraction that equals a fraction, you can always cross multiply over the equal sign. Okay, so this is called the means, the extreme over the means. Just to sound fancy math geeky here. So I'm going to take the 5 and times it to the 6, which would give us, and practice a little bit of mental math here, 5 times 6 is 30, carry the 3, 8 times 1 is 5 plus 3 is going to give me the 80, and then an equal sign, and x times the 40, and we always put the x afterwards. And so we find that x equals 2. Divide a 40 out of each one of those. A little bit of mental math there. So if x equals 2, what was our scale factor here? That is, by how much did it get larger? And 2 times 8, okay, so our scale factor is an 8. All right, you'll see some of these as, again, a fraction equals a fraction. but we're going to have a binomial as a part of the fraction. And again, I'm still going to cross multiply because that's what happens anytime you have a fraction equals a fraction. So I have the 4 and the 9. That's the extreme. And then we're going to have the 5 times the binomial. Now here's where you have to be careful. It is not 5 times x. It is 5 times x plus 3 because x plus 3 is its own number. And now we can go and solve. First we're going to distribute. And so I'm going to get a 36 equals 5x plus a 3. Then we just minus a 3. And minus a 3, yes, it looks a little bit backwards, but that's no big deal. Commutative property, A equals B and B equals A. 36 take away 3 is a 33 equals 5x. Divide the 5 out and divide the 5 out. And we see that x here equals 33 over 5. And if you're talking any type of measurement, because proportion and ratios have a lot to do with measurement, we can go ahead and do that. And we know we've got 6 with 3/5 left over. And again, we're just going to cross multiply on the next one, just a little bit bigger, the extreme over the means. It's 3, and it's not 3 times x. I heard you. It is 3 times x plus 1 equals 4, x minus the 5. Okay, cross multiplying again. Something that you can actually do anytime you see binomials is go ahead and put parentheses around them. It just keeps things that happen to them nice and easy. Nice study skill. In fact, if you want to write that down as a whittle, that would be great. Parentheses around a binomial. Ah, there goes the cuckoo clock. And so we're going to distribute. So we can simplify both the sides. It's going to give us a 3x plus the 3. Notice I put the little circle around there. And then I do the rainbows. I have to show my eyes some place to follow. Study skills, study skill. Adopt the study skills and you'll get rid of a lot of the little silly mistakes. Okay, we're going to get the 3x by itself here, which means we are going to subtract 3 from both sides, number to number, like terms, and we're going to get 3x equals the 4x minus the 23. On the other side, remember we want a variable on one side, a digit on the other side. So I'm going to go minus 4x and minus the 4x. Ooh, almost running out of room. Can I make it? I think I can. And again, negative x equals the negative 23. Divide out a 1 from both sides or do the quick and the easy. Change the signs. We end up with x equals 23. Circle your answers. Again, I'm showing you more study skill type of things here at the same time, but just a word about proportion, and a fraction equals a fraction. Moving on along to the next slide here, I'm going to talk a little bit more about similarity. Similarity between two shapes, between two polygons. They can be everything from a triangle to a triangle, a quadrilateral to a quadrilateral, a hexagon to a hexagon. But what happens with similarity is that there is this scale factor happening here, that all the angles stay the same But what has happened is you either have a large or a small figure. I'm going to say that this started with a large figure, and then it reduced itself into a smaller figure, but it did it proportionately. That means every side had an equal scale factor between them. Now, to write this out, what we have is that quadrilateral ABCD is similar to quadrilateral EFGH. That results in the fact that angles are congruent, similar ones. So I have A congruent to E, B congruent to F, C congruent to G, and D congruent to H. But likewise, the angles tell us what sides are similar to each other. So if I'm going from A to B, and A was congruent to E, and B was congruent to F, then it is similar and has the same scale factor as going from E to F. And similarly, if I go from B to C, watching the angles here, I have 2 and I have 3, and down on the small one, 2 and 3, that BC is going to be similar, have the same scale factor as going from F to G, and C to D, and G to H, and D to A, and H to E. Make sure you keep similar letters with each other. If you started with D here, which has 4, and you're going to a 1, then on the smaller one, I have to go with H, that has 4 tick marks to it, and go to a 1 tick mark. Let's play apples to apples and oranges to oranges. You're given that triangle XYZ is similar to triangle MNO, and what you have to do is find side A here. Because they're similar, we know we have congruent angles, but we have a scale factor happening between the sides. Alright, just going from left to right here, I see that I have a large triangle. And this is how I'm going to do my setup. I do the large to the small shape, or it might be a small shape to a large shape. And it's proportional, so it's going to be a fraction equals a fraction. And there's always just kind of a small side, and then there's a large side. Can you put the large side on top and the small side on the bottom? Certainly. I'm just going to just kind of go small side to large side. It's just a matter of keeping your apples with your apples and your oranges with your oranges. Okay, and when I say that, apples to apples, oranges to oranges. All right, so let's match them up. My large triangle here, my small side is a 5. It is in between the angles that has a 1 tick mark and then a 3 tick mark. And then my larger side is 10, which is between the 1 tick mark and the 2 tick marks. Alright, moving over to the smaller triangle, I am going to look for the small side, which is between the 1 tick mark and the 3 tick mark angles. So that's going to be 2.5. We're just matching them up. And again, I'm going to go to the large side, which matches up with the large side on the larger triangle between the 1 tick mark and the 2 tick marks on the angles. Okay, here's 1. That's my oranges. And there's the 2, which is going to be A. So now we have a fraction equals a fraction, and all we have to do is cross multiply. 10 times 2.5 is 25. Quick math says move that decimal over, equals 5A. We divide out the 5 on both sides, and we see A equals 5. Okay, so A over here equals 5. Now, another way that you can do this is by discovering the scale factor. For instance, two of the sides that we have is on my large triangle to my small triangle is the 5 to the 2.5, which is how I'd set up the ratio. Because I talked about big to the small, that's what I'm going to do. Remember, that's how the ratio comparison is. Whatever you talk about first goes up top, and whatever you talk about second goes down below on the bottom. So the scale factor here would be 5 over 2.5, which reduces down to 2. So we have a scale factor of 2 to 1. And if you really wanted to, you would go, oh, well, this is like, half as much. So the A is going to be half as much at 5. Another thing that happens inside triangles here have to do with parallel lines. And as you remember, that parallel lines, when they have a transversal, give us very cool angles. So right along here, I'm just going to kind of show you a bit of a transversal happening. Of course, each side of the triangle is actually a transversal to the parallel lines. So we have cool angles going on. And because we've got these cool angles going on, we also have some similarities happening. Now what's unique about these is instead of having two triangles side by side, what we end up with is two triangles, one inside of another. So right here what we have is a small triangle, and then we have a larger triangle, a small and a large. Because we got these parallel lines and we have angles that all equal each other, we have a thing called the AAA similarity between two triangles. Angle, 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 similarity. Postulate. Okay? And we know these two triangles have same angles because they share a top up here. And because they share it, it's reflexive. They both have same angles. If they're same angles, they're similar. If they're similar, they're proportional. If they're proportional, then they have a scale factor between the two of them. So again, we can set up things apple to apple and oranges to oranges. And so I'm going to start with a small triangle. Always start with the shape up top. Setup is key here. Large triangle. And a fraction equals a fraction. You always have a small part and a larger part. This is your apples and your oranges, and a small part to a large part. Okay, so I'm going to start with my small one. The small side is 9 and the large side is 10. And then I'm going to move over to the large triangle and do the corresponding things. The small side, the 9 here is between the 2 ticks and the 1 tick, so the corresponding thing here is going to be the X, same thing. It's between a 2 and a 1 tick on the angles here. So that's the small, and it's going to be an X. And then we're going to do the large side. Now you got to be careful here because the larger side here is 10 of the small and 8 of what's left over, or 18. And so now we're just going to cross multiply to go and find it. And we end up with 10x equals 9 times the 8 is 72. Carry the 7 is 162. We're going to divide out the 10. Practice a little bit of your decimal stuff. If you divided 10 out of anything, it's just moving the decimal over one place there, making it a little bit smaller. And we get 16.2. And you can find the scale factor from the small to the large, and it would be the same thing as the 9 over the 16.2. We just match them up. where it would be the 10 over the 18. I think the 10 over the 18 might be a little easier to simplify, although you can just try it with your calculator. Would leave you with a 5 over 9. Let me make sure that 9 divided by 16.2 yields the same thing. 9 divided by 16.2. Math key, enter, enter, and lo and behold, it also equals 5 over 9. So we have a scale factor of 5 to 9. Moving along to the next triangle, this one just has 3 inside here. Similar things are going on. Because they're parallel, we got cool angles, corresponding angles here. The top one is, of course, congruent to itself. And so they're similar because of the AAA similarity postulate. So we can actually, in theory, take the small triangle, let it be similar to the medium triangle, which is, of course, going to be similar to the large triangle, and set up our 3 ratios here. And I'm still going to let this be small, bottom one be large, and then small and large. We have to go find A and B. So I definitely have all my information here for small, so I may as well start there to begin with. And put the small to the medium one. Let's see, my small side's going to be 5, and then we have 35, and then I'm going to do my medium one. My small side is A, and my medium, let's see, the large is going to be the 35 plus the 21, putting them together, which is what, 56. Very good. Alright, so now we're just going to cross multiply these together, and we get 35A equals 5 times 56, 5 times 6. Practice some mental math while you do this. Don't try to rely everything on the calculator. 5 times 6 is 30, carry the 3. 25 and 3 is 28. We're going to divide by a 35. And so A is going to equal, let's see, if we divide both of these by 5, 280 divided by 5 is 56. 35 is going to be 7. Is 7 and 8 actually 56? I believe it is. So A is going to equal 8. Awesome. Alright, now with that one down, we can actually set up the large one, and you can either set it to the small one here or the medium one because you have both. Your choice. But since I already have my small one here, I'm going to do 5 to 35, and the small side is going to be B, and the large side is everybody added together, 35, 21, and 4, which is 60. So we get 35B equals 300. And that means we're going to divide both sides by a 35. So B is going to equal, let's see, 150, 150 is, okay, hold on. Something that we can reduce, and we can divide everybody by a 5, which is going to give us 60 over 7, or 8 And so this one is 8 4/7, just a little bit larger. So you can find all the sides of a triangle just by using your A similarity. Apples to oranges.